morning one and all. I am Sampujya of 9th standard. I stand before you to explain the topic Theorem of Perpendicular Axis. When you consider the theorem of perpendicular axis, we take the 3-axis coordinate system. In this coordinate system, the distance, this is a particular point for which we are going to find the moment of inertia. The moment of inertia, with this point, we need to know the distance first. The distance made by this point with respect to x-axis is y, with respect to y-axis is x, and with respect to z-axis it is going to be r. When you consider this carefully, we find a right angle triangle. We know the Pythagoras Theorem. According to Pythagoras Theorem, hypotenuse square is equals to side square plus side square. In this triangle, the hypotenuse is r. So, r square equals x square plus y square. According to this theorem, the moment of inertia is generally defined when an object of mass m is placed at a distance r. The moment of inertia of the object is given by half mr square. Now, when you take along the x-axis, as the distance made by the object with respect to x-axis is x. So, half m x square. With respect to y-axis is half m y square. With respect to z-axis, it is half m r square, as the distance made by the object with respect to z-axis is r. So, according to the theorem of perpendicular axis, moment of inertia along z-axis is the sum of moment of inertia along x-axis and that of y-axis. So, we will prove this. Moment of inertia along x-axis is half mx square, as we know. Along y-axis is half my square. So, when you add this, I take half m in common. So, we get half mx square plus y square. As we proved x square plus y square is r square, I substitute that in this equation. I get half m r square. As we know, moment of inertia with respect to z-axis is half m r square. So, it is proved. This theorem is applicable only to planar bodies, that is, bodies which are flat in nature. The example of such bodies are square, circle, triangle and a star. These bodies must be flat, then we can find the moment of inertia of these bodies. Thank you for giving me this wonderful opportunity.